So my HG15 rails have arrived. So these are pretty beefy. So as you can see, inside there's actually 4 points of contact for the bearings. So I'd never used these before. I've only used like MGN rails. I've used MGN 15s before. These are MGN 12s. But yeah, these are HG 15s. So very rigid, very smooth, and also I love the size of this block. So this is the old Z bearing system, and something I noticed when I took it off, which I guess I kind of knew about, is that it kind of feels grainy and it kind of gets stuck in places, but even when it's not getting stuck, it just kind of feels a little bit grainy. And I don't think these are necessarily cheap. I guess they're old. These are from the K8200 printer, and I think they had reasonable quality bearings. Yeah, they're definitely old. But this, on the other hand, is really smooth. The HGR 15. So that is one improvement. And then another improvement is these big 5mm mounting screws and kind of how far apart they are. It's gonna work really well. So progress is almost complete, and this is way more rigid. So particularly if I like push down here, it's way more rigid than what it was before, and it's way more smooth with these bearings, and it's more rigid like in every direction pretty much. So pretty happy with that. I've got 30 tooth pulleys there and 16 tooth pulley there, so it's going to be nice and accurate in that regards. It's a small stepper motor, but that's okay because of the reduction and all that, so it should work pretty good. So I put this gauge here so I could measure the wobble of the bed after all these changes, but something I've just realised is that's just set up now with it touching the bed, and if I just wobble the printer, it even moves. Probably not a lot of people realise that, and I don't know, I feel like I did a pretty good job of bracing, but obviously I can do better because it's wobbling, I guess, 0.01 of a millimetre, I think that is, probably, if I just wobble the whole printer. So that's interesting. So I've just put this side panel on. It's like maybe 3mm, like some kind of acrylic or something with aluminium top and bottom. Not really sure what it is, but I've put bolts all around this M3. I just tapped into this aluminium and then put some bigger ones into there. So basically I've just bolted up that side, and if you look at the dial, when I shake the top, it's much better. So basically I've definitely fixed the forward back movement, but if I do hold both sides and then kind of torsionally twist it, there's a little bit of movement there, but I guess I really just need to put more panels on and screw them on nice and tight, and that should fix it all up. So this is way better. This is amazing. And that going up and down a little bit is because of the bed mesh. Look, everyone's going to have their own different standards as to what's good quality, but for me, the quality on this thing is just ridiculous. Especially given the speed, you know, like, so it's 5k acceleration perimeters and then 50k acceleration everywhere else. I don't know what the print speed is at the moment, so this is a 0.3mm nozzle. Whoop, shit. That wasn't supposed to happen. This is a 0.3mm nozzle, and I still haven't worked out the maximum flow. Probably around 200mm per second, maybe more, I'm not sure. I think this is going at like 180mm per second right now. I can definitely bump it up a little, but I don't know how much I can bump it up. Alright, so I got my enclosure basically built. I mean, that's a bit of cardboard, but I got the door on. So I'm using the K3 hinges, the K3 handles, and I've got little magnets and a magnet there. So one thing I didn't consider is how much it quietens down the printer, so that's really good. So another thing that I've done is I have swapped these sense resistors for 0.1 ohm. So it's 2 resistors on each board, and that allows me to get better current accuracy. I think it drops the maximum current, the maximum readable current to like 2.3 amps maybe. But yeah, better current accuracy for these stepper motors, so they run a little bit cooler. So the heat bed on this, that's from the K8200. So I believe that was a 15 volt printer. So it's designed to run on 15 volts. But I'm running it on like 26 volts or whatever. And the maximum temperature I can get is like 70 degrees Celsius. So that kind of gives you an idea of how bad this heat bed was on the K8200. It was always a problem trying to get it hot enough for even PLA on the 15 volts. But I don't know, I want to keep using this. Partially because I can't be bothered, you know, massively changing everything, and partially because I've spent money on this and I don't want to spend more money on this. I don't feel like spending money at the moment. And I guess I'm almost there with the temperature, and I was trying to think of ways where I can just get a little higher. I mean, maybe 100, or I want to be able to print ABS. So I've got an idea, and that is I made these little blocks, which maybe I'll call them booster blocks. So, and I've tapped a hole there. I'm going to bolt that there, and that hole is for a cartridge heater. And what I've got is 2 cartridge heaters in series. So hopefully to lower the load on them, because I don't know how this is going to go. I'm hoping there's not going to be a meltdown or whatever. But anyways, so I'm going to put a booster there and a booster there, and we'll see how hot we can get. So I've got a nice amount of thermal paste there to get some decent conductivity. So I've got these 2 heater cartridges. They say 24 volts, 70 watts. Did the maths on that. That means they're 8 ohms each. And if I put them in series, that's 16 ohms. And I think that was 42 watts that should give me. So presumably that's like 21 watts through each one. So I don't know. That might give me a little boost. We'll see. Alright, so we're wired up. It's a moment of truth. I guess we'll set the bed heater to, let's go 100, why not? No fire so far. I think the MOSFET can handle that, so. Okay, that feels a little warm. It's starting to warm up, so. Yeah, interesting. So these are definitely the hottest part. I don't know if that's going to become an issue. What's the heat transfer like? And then obviously the other concern is, am I going to create hot spots? Because that feels really hot there. And obviously it's not hot at the back, but it's a chunky 6mm aluminium thingy. So I mean, my hopes are that the heat would transfer around. I don't know, this might be a terrible idea. So this is obviously a real concern of mine. 63 degrees there, and then 46 at the back. So I mean, it's still heating up. So my hopes are that it will, you know, even itself out once it gets to temperature. But yeah, that is a real possibility that I'm just creating hot spots. So that wasn't enough heating, so I am persisting, and I've managed to find 4 12-volt heaters. Got them all in series, so hopefully they won't get too toasty. And I'm going to bolt that to the back of the bed, which will also help with the heat distribution. So this is getting more and more ridiculous, but hopefully we can get there without spending money, because this is free. This piece of aluminium, just a piece of junk. It's got holes all in it, but it's the right thickness, so we'll see how we go. Alright, got that bolted on. Nice healthy dose of RTV, so I don't want these to come off at all. So that's annoying. Still don't have good adhesion. That's actually coming off the bed. It's warping. So, you know, I've cleaned the bed with isopropyl. The first layer height and precision is like on point. Running 110 degree bed. Chamber temperature is like 43 Celsius. So I don't know what else to try. I did increase the line width of the first layer to 0.4 millimeters because it's a 0.3 millimeters nozzle. And I'm going pretty slow for the first layer, I think like 100 millimeters per second. So I don't know. You know, and the fan, the CPAP is at like 10%, I think. Because I figured if the part's getting cooled, maybe that's pulling it up. So I don't know. I think I'm going to give up for today. But anyway, I'm almost there, I think.